All right, hello AP. 2.6 is talking about molecules and molecular compounds. First of all, make sure you understand the difference between a molecule and a compound. A molecule is usually at least two or more nonmetals that are bond tightly together. Usually compounds, we refer to compounds as like ionic. Okay. Now you can call a compound also molecular, but you can't call a molecule a compound. Okay. So when you have a sodium chloride, that's a compound because it's an ionic bond. But you can't call sodium chloride a molecule because it's not a molecule. So I know sometimes the distinction between molecule and compound can get a little bit confusing. So just tend to connect if you have nonmetals only in that bonding type of structure, then it's a molecule. Now, what does the formula always tell you? Well, if I had something like this, okay, MgSO4, first it tells me which atoms are in this molecule or compound, and it also tells me the number of each. So I know I have 1 magnesium, I have 1 sulfur, and I know I have 4 oxygens that are in this compound. So in every chemical formula, it tells you who's the players of the game, and it tells you how many you have of each one. Now, we always got to remember those diatomics, those 7 diatomic molecules. These 7 elements, they only exist either with themselves or in another structure with another molecule or compound. So like chlorine is either bonded with itself or bonded with nonmetals or bonded with metals. Okay. Now remember our little trick on the periodic table to remember those. Makes that 7 on the periodic table. So you got nitrogen, you got oxygen, fluorine, chlorine, bromine, iodine. So it makes that 7, and then don't forget our favorite element in the corner, Mr. Hydrogen. So once again, the 7 diatomic molecules, when you name them, it always trips students up. So if I just said like H, well, that's a hydrogen atom. Okay, but if I say H2, sorry about that, if I say H2, then that's not an atom no more. I have 2 H's bonded together. That's a molecule. Okay, you don't start changing the names of the ending like IDE or ATE or ITE until you start putting charges. Okay, so when you start having these type of endings, or ITE or ATE, is because you're talking about ions. You're talking about charges. Okay? So in 2.6, when we do these problems, some of the key questions you're going to see is between molecular versus empirical formulas. Okay? So what first is these type of formulas? So chemical formulas that indicate the actual number of atoms is usually called a molecular formula. But if you actually have a formula with the smallest type of ratios, the smallest whole number ratios, it's usually an empirical formula. So like an example would be for an empirical formula, like the smallest possible ratio. So if I look at this carbon, hydrogen, and oxygen molecule, I know I have a 1 to 2 to 1 ratio. But what could be an example of a molecular ratio? Well, molecular ratios are usually bigger ratios. So like maybe like glucose. That if I wanted to, I could reduce those subscripts maybe by 2 or by 6, and I can get smaller and smaller till I can't divide or get any smaller. So molecular formulas are usually the true amounts that are actually in that molecule, and then empirical formulas are the smaller whole number ratios. Okay, so like for example, hydrogen peroxide, a 2 to 2 ratio. If I wanted to, I could actually reduce each one of those by the same number, by 2, and then I get this formula for empirical formula as an HO, because now it's 1 to 1. Or if I took this molecule C2H4, and if I divided each one by 2, then I get this empirical formula for CH2. Now, very rare can you actually have a molecular and empirical as the same formula, and it is out there because water. I mean, I have water that's 2 to 1 ratio. I can't reduce 1 because you can't have half of an oxygen. You either have it or you don't. Okay, so for example, if you had like Al3O6, so if I asked you, is that an empirical formula or is that a molecular? So the first question you got to ask yourself is, can you reduce those subscripts any further? And in this case, you can. I could divide each one by the same number, and if I divide each one by 3, then I could technically get Al1, which we don't write ones, and then O2. So this would be an empirical formula, and then this would be an example of a molecular formula. So hopefully that helped you distinguish between what type of formulas are molecular or ionic type of formulas, and then molecular and empirical formulas. Okay? All right, see you on the next one.